Okay, we are going to pick up at naming ionic compounds with polyatomic ions. Now, we mentioned polyatomics as a vocabulary word that we were going to look at, so let's go ahead and kind of break that down. So when we're thinking about this word, poly means many. And we know based on what we saw, atomic means it has to deal with atoms. And we know that ions are charged particles, or that something has a charge. So when we put that all together, what we're saying is that this is a group of atoms so there has to be two or more that has a charge. So a group of atoms, so two or more of them, that has a charge. And we'll talk a little bit more about how these are structured when we get to covalent. But for right now, we're going to look at them as one thing. So a polyatomic ion may have two elements, like ammonium, but we look at it as if that is one thing. So this ammonium has a +1 charge. That's why there's a plus right here. So we treat that just like a singular cation. And that's what we're going to do for the whole time we're kind of working in our ionic compounds. Now, I've listed on here some common polyatomic ions. Most of these are on the back of your periodic table. And if you need that, it is posted on Canvas. Right here where it says ions. Okay, a little shiny, but the only ones that I want you to be aware of that are not on there are written in red right here. Now, hydroxide is one you have to know. Okay. So, that is the only one that's not on the back of your periodic table that you have to know. Cyanide and acetate you may see. They may come up in practice problems and examples if you're searching for things online. So I want you to know what that is. The other note that I've put on here is about bicarbonate. On your periodic table, it says that it's hydrogen carbonate. Why? I don't know. But I will always call it bicarbonate. So I try to not put that on a quiz or test or anything. But if you see that, please just be aware. I will try to remind you of that as we go through this process. So if you would like to write those down, feel free to do so. I would definitely write the ones that are in red and bicarb right here. Put a little pink star on that. So those are the four. If you don't want to write the rest of them down, that's fine. They're on the back of your periodic table. But those four you definitely need to know. Now let's talk about what in the world we're going to do with those. So the very first thing we're going to look at is naming ionic compounds with pattern metals. So remember, our pattern metals are group, bless me, we're talking groups 1, 2, and 13. When we're naming these, we're going to use a very similar process to what we've done with these pattern metals before. So we're going to write the metal name plus the polyatomic ion name. That's it. Okay, metal name, polyatomic ion name. So let's take a look at these. K. I know that K is potassium. If you're not remembering those yet, I promise you will as we work through them, but definitely use your periodic table. Okay, NO3. If I look at the back of my periodic table, I find NO3, and it says that that is a nitrate. So now I know that I have potassium nitrate. Let's check out our next one. I have Na2SO3. Now this subscript of 2 just tells me that I have 2 of this thing. It's not affecting my naming here because these are pattern metals. I already know their charge. I'm not having to do any additional calculations. So I just need to know what Na is, and that is sodium. Then I'm going to look for SO3. So I find SO3, be careful with your subscripts, because right above it's SO4, but I know I'm looking for SO3. So that's going to be sulfite. ITE. Be careful, when we did binary, 2 elements, we talked about sulfide, IDE. Sulfite, ITE, is a polyatomic ion. So watch your endings there, because that's 2 very different compounds. Okay. BA. Remember, if you need to look, check out your periodic table. So we got barium. Now these parentheses with this subscript on the outside just tells me that I have 2 of that thing. Just like this said I have 2 sodiums, this is telling me that I have 2 of these. Again, not affecting our naming for pattern metals. So NO2, I'm going to look at the back of my periodic table. NO2 tells me that's nitrite. Now check that out. Nitrate, NO3, versus nitrite, NO2. So this ending is telling me how many oxygens I have in my polyatomic. So be conscientious there and watch those endings. That's going to be a big make or break it here. Now this next one, I know that hydrogen is not a metal, but we talked about at the beginning of these notes when we talked about those ions that we're going to write our cation first. And we know that because hydrogen is in group 1, it has a +1 charge. So even though hydrogen is a non-metal, it acts like a metal here as far as charges go. So we're looking at it as our cation. So I'm just going to write its name, hydrogen. And then CN, that's one that's not on the back of your periodic table, but it's right up here. So this is going to be hydrogen cyanide. So take a second, pause the video, and try these 4 over here, and then press play to check yourself. Okay, let's take a look at these your turn problems. So we're looking for Al, that is aluminum. In PO4, I'm going to the back of my periodic table again. PO4, so that is phosphate. Now we have K. We already said over here that K is potassium. Now OH, that is one that's not on the back of our periodic table, but I told you that was the most important additional one that you needed to know, and that is hydroxide. Now let's check out these last 2. This is where sometimes there's some questions, so let's take a look at it. I have Ca, so when that's calcium. And then I have ClO2. A lot of people think that's CiO2. It's not. ClO2. So I'm going to look at the back of my periodic table. ClO2 right here, which is chlorite. ITE. And then this last one, Mg, that's magnesium. And then remember, this is on the back of your periodic table, and they listed as hydrogen carbonate, but the more common name for that is going to be bicarbonate. Okay. So that is naming with polyatomic ions for pattern metals. So let's go to our next step and check out what we're going to do when we have our non-pattern metals. So just like we've done before, we've looked at pattern, then we've looked at non-pattern. We're doing the same thing here. So for our quote-unquote equation, we're going to have our metal name or cation name. Okay. Our Roman numeral if needed. in parentheses, just like we have been, plus that polyatomic ion name. So let's go ahead and take a look at these. So Cu, when we look at our periodic table, we know that that is copper. If you want to check out the back of your periodic table, you can see that copper has more than one charge. So we are going to need a Roman numeral there, so I'm going to leave a spot for my Roman numeral. And then NO3, again, I'm checking the back of my periodic table. NO3 tells me that it is nitrate. Sorry, it's a little shiny for y'all to see. Now let's calculate this charge. The one thing I want you to do here if you are processing through this is we need to know that NO3 is one thing. Your hand has 5 fingers, but it's still one hand. That's how these polyatomic ions are working. So if there are no parentheses around your polyatomic ion, go ahead and kind of add them there to visually help you see if there is, or how many there are of them. Or you can remember that if there are no parentheses, then there's only one polyatomic ion. We're using that same equation that we used earlier. So we have our number of metal ions, X for the charge, plus our number of nonmetal ions, and then our nonmetal charge. And we're going to equal that to 0. Now, you don't have to write that again or anything, but that way we have it on here so we can kind of remind ourselves as we work through this. So, looking at copper, I have no subscript, so I know I only have one copper. I don't know its charge. NO3 had no parentheses, so I know that there's only one of those. And then when I look at the back of my periodic table, NO3 has a -1 charge. I'm going to set that equal to 0. So there we see that X is going to equal 1. So I'm just going to put my 1 in there. Let's check out our next one. SN, right here. There we go. Right here, which is 10. Oops. So I'm going to have 10. I know it needs a Roman numeral, so I'm going to leave a spot for my parentheses, or for my charge by leaving parentheses. And then CO3. CO3 is right here, and that's carbonate. So now I'm going to go ahead and write out my calculation to figure out that Roman numeral. No subscript for 10, so I only have one of them. We're looking for that charge. CO3 had no parentheses. With polyatomics, if there's no parentheses, then you only have one of them. And then I need to look at the charge for CO3. CO3 is right here. Has a -2 charge. So I need to put -2 in there. Set that equal to 0. When you solve that, you'll get that X equals 2. So I need to put my 2 in my Roman numerals. I'm glad to write that in blue so it's a little bit easier for y'all to see. Now let's check out our next one, AU. Look on the back of my periodic table. AU is gold. It has more than one charge, so I'm going to need Roman numerals. And then PO4. PO4 is right over here, and that is phosphate. So let's go ahead and calculate the charge. Now this time I have 3 golds. So I'm going to have 3. X for my charge, because that's what I'm looking for. Plus no parentheses on my polyatomic ion here, so I only have one of them. And then when I look at the back of my periodic table, phosphate has a -3 charge. So I end up with 3x plus negative 3 equals 0. So x is going to equal 1. So this is gold 1 phosphate. Remember, you're welcome to do it with the lines on top if you prefer your Roman numerals that way. I'm totally fine with either one. Let's look at our next example. We got V. And at the back of my periodic table, I can see that that's vanadium. It has more than one charge, so I'm going to need Roman numerals. So I will leave parentheses there. And then SO4. So I'm going to check it out. I have two SOs over here. We want to make sure that we choose the one that's SO4, so 4 oxygens, and that is sulfate. And then we need to bounce in and calculate our charge. No subscript here tells me that vanadium, we only have one atom of vanadium, so we're going to put a 1. X for the charge that we're looking for, plus this time my polyatomic has parentheses around it. If that's the case, I need to look at my subscript on the outside. So this is telling me that I have 2 sulfates. So I'm going to put a 2 there. My charge on sulfate, we can see on our periodic table, is a negative 2. Negative 2 in there. And we're still setting that equal to 0. So here I have x plus negative 4 equals 0. So my x is going to be 4. Remember, 4 is 1 before 5, so IV. Let's take a look at this last example before you try some on your own. So Cr, looking at the back of my periodic table, I can see that that is chromium. It has more than one charge, so I'm going to need that Roman numeral. And then ClO. Now notice that this 3 is on the outside of the parentheses. When I'm identifying my polyatomic ion, I only care what is inside of the parentheses to name that polyatomic. So whenever I'm looking on my table, I'm only focused on ClO. So ClO is right down here, and that is hypochlorite. Now let's jump into calculating this charge. I only have 1 chromium, so 1, X for the charge that I'm looking for, plus I have 3 hypochlorites. I'm going to put 3. When I look at my charge here, you can see that. There we go. Have a negative 1, so I'm going to put my negative 1 in there. And I'm still setting this equal to 0 because this, as a compound, has no charge. So I end up with x plus negative 3 equals 0. So x equals 3. So I'm going to put my Roman numeral of 3 in here. Pause the video, take a second, and see if you can answer those 3 your turn questions. Okay, let's give those a shot. So, Fe, if I'm looking at the back of my periodic table, Fe is iron. You're welcome to look at the front too, but if you know that it may need a Roman numeral, this is probably going to be your quickest way of finding it. So, Fe, that's iron. Iron has more than one charge, so I know it needs a Roman numeral. I'm going to leave my parentheses. And ClO2. ClO2, so that is chlorite. And now we need to calculate our charge. I only have a 1 iron, so 1 X for the charge I'm looking for. I have 2 chlorites, and chloride has a negative 1 charge, so I'm going to set that equal to 0. So X here is going to be 2. So this is iron 2 chlorite. Okay, let's check out our next one. Ni, that is nickel. You can tell from the back of your periodic table that nickel has more than one charge. So I'm going to leave parentheses for that. And then Cr2O7, we'll look at the back of our periodic table. Cr2O7 is right here, and that's dichromate. And now we need to calculate our charge. We only have one nickel, so I'm going to put 1, X for the charge I'm looking for. Since there were no parentheses around my polyatomic ion, I know I only have one of them. And based on my periodic table, it has a -2 charge. And I'm setting all of that equal to 0. So here my X is going to equal 2. And I just need to put a Roman numeral of 2 in my parentheses. Now let's check out this very last one, Hg. So Hg is mercury. Mercury has more than one charge, so I know I'm going to need Roman numerals, so I'm going to leave that open there. And then CrO4. So CrO4, and it has a -2. Oh, sorry. CrO4, jumped ahead, is chromate. Now let's calculate its charge. So I have 2 mercuries, X for the charge that I'm looking for. There's no parentheses around my polyatomic, so I only have one of them. And based on what we just saw on our periodic table, it has a -2 charge. So I end up with 2X plus -2 equals 0. So X equals 1. So this is mercury 1 chromate. So that was a look at what are polyatomics, what are some common polyatomics, and how do I use them to name with pattern metals and with non-pattern metals.